So when it comes to Venn diagrams, I guess I need something a little bit stronger than that. And yes, my handwriting is that horrible. There's a reason I'm not an art teacher. Okay. When it comes to Venn diagrams, a lot of times when we look at them, we're basically going to have some sort of a box, and then we might have, say, two or more circles. So we can have something like that. Or we can have two or more circles, something like that. And when you look at the Venn diagram that's at the end of the worksheet, you can even have, say, a couple of circles like that. Are you limited to two circles when we're talking about a Venn diagram? Absolutely not. If you start getting or start doing too many things all at the same time, it can get to be really, really, really confusing. Okay? Um, and what's happening here is I'm going to call this circle A, this circle B. I'm going to call this circle C and the circle D. This outer circle is E, and the inner circle is F. And what we're trying to say here when we're looking at this is we've got two groups, A and B. We're using mathematical terms. We're probably going to call them something, or we're going to call them a set. So definition here, if you look on the worksheet, they have a really firm definition of what a set is. Um, but a lot of times, how many of you have ever looked at a mathematical definition and read it three or four times and went, what? What does that mean? I've got two honest people. All right, four, a lot more honest people. Okay. So basically, a set, we can think of this as a group of interest or a group that's been defined. So what do I mean by that? We could come out and say group A is one, two, three, four, five, six, or something like that. We could say B is, say, two, four, six, eight, 10. So we can make these numeric sets like we have here. In math, a lot of times this is what we're going to be doing. But if you get into psychology, sociology, history, that sort of stuff, we can also say that uh, A is a certain group, and then B is another group. And with both of those, I'm talking about groups of people. So we may say group A are female students here at SVSU, group B are engineering students here at SVSU. Okay. So with either of these, so let's just say these are the females and B are engineers. What we would have here So in this section here, where we've got this overlap, would be female engineering students. Okay. If we're looking at group A and group B being the numbers that I've got here, this overlap area here is going to be everything that these have in common. Okay. So if I look at 1, 2, 3, 4, 5, 6 versus 2, 4, 6, 8, 10, what do they have in common? They both have a 2, they both have a 4, they both have a 6. Okay. So if you get into some of the further math classes, if you get into statistics classes, what you're going to end up with is a formula. That'll look like that. The P just means probability. We probably don't even need that here. But A, and then this U here stands for union. It's going to be A plus B minus A, and then this is an upside down U, B. So what exactly does that mean? When it's right side up like that, the U actually stands for union. What's an easy way to remember what a union is? Think about it as getting married. Sometimes a marriage is called a union, right? What happens when you get married? All of your stuff and all of your partner's stuff become, like, say, family, marriage property, right? You're combining the two. The upside down U that I have here is called the intersect. So with the intersect, this is just basically that overlap we're talking about. So again, if we're thinking about this in terms of, say, a marriage, person A, union, or gets married, person B, what is the marital property now? Everything person A had plus everything person B had minus this overlap. Why do we subtract that out? Otherwise, we're going to double count it. And you can think of the stuff that's in the intersect as, say, being the stuff that was bought after the marriage. So, like if we're, let's say the couple here ends up getting a divorce, person A is going to get all of their stuff, right? Person B is going to get all of their stuff that they had before the marriage. And then basically the overlap or the intersect, that stuff that should be shared equally, right? Does that make sense? So when we're looking at all this stuff too, we can have some other really, really awkward notation. So again, if we're looking at A and B, and let's say these are what we're dealing with here. So if I say A union B is equal to everything that's in A plus everything that's in B minus everything they have in common, and you end up with 1, 2, 3, 4, 5, 6, 8, 10. That should be a 5 going there. Okay. So it's a little bit off. So if we have A and B as all female students here and B as all engineering students here, the union would be all female students and all engineering students. Okay. If we're looking at these two over here, we can say these are mutually exclusive. Meaning what? Do you see any overlap between those two things? No. An example would be, let's say, I'm going to say that C is all odd numbers. D is all even numbers. And hopefully I'll remember the difference between even numbers and odd numbers. If you can divide it by 2 with 0 remainder, it's even. If you divide it by 2 and you get a remainder, then it's odd. An easiest way to come up with that. Can you have a number that is both even and odd? No. Since there is no overlap, we can say that those two sets are mutually exclusive. And if you think about this in, say, relationship terms, mutually exclusive, that basically, or that would normally mean what? The person you're with, you're only with that person. You don't have like 2 or 3 other boyfriends or girlfriends on the side, right? Or you're not trying to date multiple people simultaneously. But here, the definition means that there just is no overlap. They have nothing in common. So you can move on. When it comes to things that are mutually exclusive, outside of me just randomly picking different sets of numbers, it's actually really, really hard to find anything that is mutually exclusive in reality. Because if you can think of one instance where something fits into both categories, it's no longer mutually exclusive. And I've had students try before, and without coming up with something like all the numbers less than 10, all the numbers greater than 20, or something like that, it's really, really hard to come up with a group that is actually mutually exclusive like that. So if we're looking at this, what we would say is F is a subset of E. So what do I mean by this? Let's say I make E all the odd numbers. And let's say I make F 3, 5, 7, and 9. Hopefully you remember that 3, 5, 7, and 9 are odd numbers. What is E? All odd numbers. So 3, 5, 7, and 9 are odd numbers. Because of that, we can say that F is a subset of E. What does that subset mean? If we're looking at, say, all of you that are here in class right now, I can say everyone that's sitting in the front row right here are the 3 people sitting in the front row right here in our class. Yeah. So they would be a subset of the entire class. We can look at, say, everyone in class, and then all the guys that are in class. Are the guys that are in class part of the class? Yes. So some of these can get to be a bit odd and a bit awkward to try to deal with. Let's see what some of the things we have on here are. So looking at this, you can see Venn diagrams definition one, a blank is a collection of objects. Each object in the set is called an blank of the set. We denote sets by capital letters, for example. Well, you can see how I already wrote it. And it's kind of giving you a hint about what one of your answers should actually be in here. So the definition we have here is a set is a collection of objects such that each object in a set is called an element. And you can see here it says something about a list of elements. So based on what we were just looking at, if group F is 3, 5, 7, and 9, that would be the set. 3, 5, 7, and 9 would be the elements of the set, or the things that are in the set. And then we denote set by capital letters, for example, capital C. So for example, here it says write the days of the week when classes are set, or as a set denoted by C. So what does that mean? What days do we have class on? And there are a couple different ways that you could actually look at this. Since it's telling us write the days of the week, what days of the week are we here? So that would be our set. If it just came up and said, write the days when we are in class, what would that mean? You could interpret that as days, Monday, Wednesday. You could interpret that as every single day that we're actually supposed to be in class. So this week could be what, August 25th and August 27th. Next Monday we have off because of Labor Day. So that's what, the first. But we could actually come down here, look at the calendar. So if we just said, what are the days? 25th, 27th, September 3rd, so on and so on and so on, right? So when you read some of these, there might actually be more than one way to interpret it. One of the things that happens in math and statistics is we will have very firm definitions of what we mean by certain terms, like say day. And then when you look at all these terms in the dictionary, are they going to be in the dictionary? Yeah. But they might be the 7th or 8th definition as opposed to the first 2 or 3, which can make things really, really difficult. So down here it says, write all positive numbers as a set denoted by E. Well, what does that mean? Well, what are all the positive numbers? Hmm? Well, it just has to be positive number, right? Is there any limit on that? Can you have decimals? Is 50 cents a positive number or a negative number? So 0.5, is that positive or negative? So you can have decimals. How do we try to discuss what all of these different values can be? So again, when you start looking at things in the textbook, you might find that there's something written where we have R, or we're going to have the extra line in the R like that, which is admittedly really weird. Maybe that's not doing well. So you can almost see what's going on here. Oops. So why do we write R with the extra line in there? Anybody want to guess why? You want? You'll see things like R, or you might even see something like C written like that. Why do we have those extra lines in them? It's because way back in the day, like 1400s, 1500s, a lot of the mathematicians at the time were writing in basically Old English lettering. I'm sure we've all seen the Old English D around town because it's what Detroit Tigers. You look at all the other letters and you're like, why are they so fancy? Why? Imagine trying to write out something where everything was written in those Old English letters. Well, what are you going to find a lot of times? There are just extra lines in there rather than say, hey, we don't need these extra lines. Let's not use them anymore. It's because it's tradition now, we carry it on. And what happens here is R is going to be written as real numbers. And what does real number mean versus down here versus complex? Real numbers are basically the numbers that we encounter every day. You go and you buy gas from the gas station, the amount of gallons of gas that you bought, that's a real number. The amount of money you paid for the gas, that's going to be a real number. Complex numbers, I probably won't get it shown in this class, but anyone remember using a square root of -1 and having an I pop in there? That makes it complex. Well, real numbers are just basically every number that we would normally deal with. The range here uh, can basically go from -infinity to +infinity. So if we want to say all the numbers that are positive, a couple different ways we can do that. But a lot of times it just ends up being something like that. There are going to be a lot of different ways that we can express these numbers. But usually if you just put a plus at the end, it means all positive numbers. Sometimes you'll put that plus up here as an exponent. Sometimes it'll just be out where I've got it. And all that is saying is we want all positive numbers. We can't write all positive numbers. So we use the symbols that we've got there to say we want all positive numbers. If we can also have, say, I which will be all integers. And when we start thinking about numbers, most of the time we think about integers. So what are integers? 1, 2, 3, 4, 5, 6. So numbers that do not have decimal points after them. So some of the stuff, I admit, it's really weird to look at. And some of the definitions can be a bit awkward. So for the third thing here, it says, write all months of the year that begin with G as a set denoted by M. Then down here they have an S. Anybody want to guess if that's a misprint? I didn't do this. That actually reminds me, uh, when we're doing some of these problems, if you catch me doing the wrong problem or put a wrong number on the board, uh, everyone that's in class that day gets 2 points of extra credit. If you're not here, you don't get the points, all right? And last term, I actually had a student who was in class pretty much every day, and she caught me making 3 mistakes. Everyone in class that day gets the points, even if only one certain student finds me making a mistake. So with her participation, uh, in her class, I think it was 11% of the final grade, but because she had all the extra credit, she ended up with 12% instead of 11. So she was actually able to get bumped up an extra, like one extra grade at the end. So instead of being B minus student, she got to be an A student. So, but this isn't something that I wrote. But what are all the months of the year that begin with G? Can you think of any? So for that particular problem, we want a set denoted by M, but uh, we know that there are no months that begin with G. So the way that we show that is to write something like that. So a circle with a line through it, not a zero, not an O. It's got to be a circle with a line through it. If you don't put the line through it, uh, you basically are going to get the wrong answer. So if I say n equals those are not the same thing. This is saying there is an element in the set, and that element is 0 or the letter O. Can anyone here tell the difference between a 0 and an O? Right. So you're saying that there is something in here. It's either the letter Z or the number 0 or the letter O. Up here, you're saying there's nothing in there. So it's weird, but we'll actually call this the null set. Null just meaning there's nothing there. So if you were all to look or go on the Canvas right now and look at your grades, do I have anything written down or for your grades? Do you have any points at all in the class so far? No. So right now, all of your grades are the null set. By the end of today, there will be some questions for you to answer. You will be able to have a grade, and hopefully your grade won't be 0, right? See what else we need to talk about in here. So you can see the set C is well, we're looking up here. What type of a set is it? We're talking about days of the week, so names of days. And in this case, because we're here 2 days a week, it has 2 elements. E is all of the positive numbers. So it actually has an infinite number of values we can put in there. How can you tell if something is infinite or not? Just start easiest way if you don't understand what some of these problems are trying to ask of you, just start putting numbers into whatever formula we get. So if I ask you, is it a positive number? Is 1 a positive number? Yes. Is 10.7 a positive number? Yes. Is 100 million billion trillion gajillion and 6 a positive number? Yes. Is every number in between all of those a positive number? Yes. If you can think of a really, really large number and it still works, then you can think of a larger number and it still works. That kind of tells you that it's going to go on to infinity. So here it says set M is a null set, meaning that it has 0 elements. Let's see. So here we're getting into some of the stuff that I was talking about earlier. So this A union B like that just means everything that's in both sets. So if I write out, if I come out and I say, just as another example, I come out and I say capital A is 0, 2, 4, 6, 8, and capital B is 1, 3, 5, 7, 9. A union B is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A intersect B. Are there any numbers up here that are in the same thing down here? No. So we have A intersect B. So looking at what do they have in common? There is nothing they have in common. So that's going to be the null set. So see down here, a set of objects are often created by grouping objects based on what properties they have or don't have. As an example too. So looking at what we have here, the N, why do they denote it as N? And if you look, you can again see double lines. And why are there double lines there? That's from tradition. And they've got N written as 1, 2, 3, 4, comma, dot, dot, dot. Does everyone know what the comma, dot, dot, dot means? Yeah, kind of like this class. It goes on forever and just never stops. Or kind of like my grandma, she'll go on about something and just never stop, then complain about how much her mouth hurts after talking for 4 hours straight, and you haven't heard a word she said. So, and I think a lot of you do the same thing to me, right? You were here, you were listening, but what did I say? I don't know. But with the N, a lot of times what's going to happen is the N is we're talking about numbers that are positive. W stands for whole numbers a lot of times. Will it always be this every time you do everything forever? Absolutely not. So what you have to look for here is what are they trying to say? So if we're looking here at N and down here at W, what do they have in common? They all have a 1, they all have a 2, they all have a 3. We see a 4 here. Well, we don't see the 4 down here, but the comma dot 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 means This goes 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to positive infinity. This means the exact same thing. So it just goes on and on and on and on. So what do they have in common? Everything that's up here in N. So if we're looking at through these things, everything in N is going to be everything in W, which means N is a subset of W. If you look at Z, you can see the same thing. The dot, dot, dot here, the dot, dot, dot back there. So what's that mean? -4, -5, -6, -7, out to negative infinity. The dot, dot, dot in front of the 4, 5, 6, 7, 8, 9, 10, everything in positive infinity, which would mean that everything in N is going to be contained within Z, which means N is a subset of Z. Everything in W is contained in Z. So W is a subset of Z. So if we were to try to create a Venn diagram of that, so based on what we have here, we'd have a circle. So that's going to be W, or sorry, that's going to be Z. Then we're going to have another circle. That's going to be W. Then we're going to have another circle inside of that. And that's going to be N. A lot of times, if we're looking at a Venn diagram, one of the things we try to do is give you an idea of the size of these different things in relation to each other. So Z is the biggest circle because Z has the most elements in it. W is the next largest circle because it has one more element than the other one. And is that a little bit better?
Yeah. Thank you.
So, sorry about that. And then N, because it has the least number of elements compared to everything else, is going to be the smallest circle that's in there. So if we have, let's say, set C, which I'm just going to have a 0, 1, 2, 3, 4, 5, and set D, let's say 0, 2, 4, 6. So something like that. If we're going to try to draw a Venn diagram of these, C has 1, 2, 3, 4, 5, 6 different elements. So it's going to be a large circle. D only has 4 elements, so it should be a smaller circle because 6 is greater than 4. And because of the overlap of 2, 4, and 6, we'd probably actually want to write it like that. So in here, we'd have the numbers 0, 2, and 4, because those are common between both of these. Out here would be the 6, so just one number out there. And then inside of this bigger circle, we've already got 0, 2, and 4 accounted for. So what's left over? 1, 3, and 5. So if I tell you that this is C, and this is D, and let's say that's the picture that I gave you, I could now ask you questions. What's in set C? Well, what's everything that's in that circle? 0, 1, 2, 3, 4, 5. What's in set D? Everything that's in that circle, 0, 2, 4, 6. What's the intersect? Everything that they have in common. Okay. And yeah.
That the,
Hmm?
for the Venn diagram,
That's a D.
sorry,
Like I said, my handwriting is poor. So that is actually a D. And how many of you are now thoroughly confused about all the stuff? Well, you know what happens? You've all had enough math by now. You should know that what happens in math? It gets worse, right? So we've got all of these values here. We can start looking at uh, coming up with some of these definitions. So I can say, based on what we were just looking at, we're looking at W based on what we had on our sheet. So this is 0, 1, 2, 3, and then dot, dot, dot. And we have Z. So again, Z with the double thing, and then W with the double lines there is dot, 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 -2, -1, 0, 1, 2, dot, dot, dot. So if we're talking about W in relation to Z, and then I can put like a bar on top of that. So what that's telling us is it's not in W, but it's in Z. What are all of the elements that are in Z, but not in W? All the negative elements. And just math. Again, this is math. Math always gets worse. If you're in a stats class, you put a line across the top of it like that. What does that mean? It means the average. In this class, it means not. In statistics, it means average. You get into some other math classes and that'll have different meanings as well. How do you keep track of everything? Good luck if you figure out a way to do that, other than trying to do hundreds of these problems. Let me know. I'm definitely interested. Okay. So see, what else do we have here? Right, so looking at this, a blank is a number that can be written as P divided by Q, where P and Q are integers and Q does not equal 0. And then it says in here, in decimal form, a rational number is either terminating or repeating. Anybody want to guess what goes in the blank right here? It's already highlighted. A rational number. Okay. So what does this actually mean? So if you look up here, if we're talking about a rational number, I should be able to take two integers and have it one divided by the other, and whatever value I get, that's going to be a rational number. Where it says it's either terminating, what does that mean? If I say P equals 2, Q equals 3, P divided by Q is going to be 2 divided by 3. If you do this with your calculator, you're going to get a number. That number is going to be rounded eventually. But it's going to be like 0.6666666, and then the last number is going to be 7. Why? Because it was rounded. But it's actually going to be 6. And then I put the line on top. What did I say about the line on the top? Up here, it means not. In stats, the line on top means average. Here, the line on top means what? It just repeats and goes on forever. So 0.66666, you just take 6 out to infinity. Don't try to write that down. You're going to be here for a long time. That just tells us that 2/3 is a rational number. If I give you P equals 1 and Q equals 2, P divided by Q, it's going to be 1 divided by 2, which is a 0.5. Because it stops after 1 decimal place, that's one of these terminating things that we have. Just means that eventually it ends. Up here, repeating. And honestly, when I interviewed for the position, the department head asked me what is a rational number. I gave the answer based on what all of you might actually see in your actual lives. He didn't like that very much. How can you tell if something is a rational number or an irrational number? If the number repeats or how the number terminates. You wanted the definition, you can take an integer divided by another integer, get the value that's up there. One of the things, if I say it repeats, here we've got the repeating number right out at the beginning. If I give you something where it's say 0.125, 125, 125, 125, and then that goes on forever, I can actually rewrite it like that. That just tells me that the 125 goes on forever and ever and ever. How do you know that it goes on forever and ever and ever? Honestly, you don't know. And a couple of the numbers that you can actually run into might repeat, but you might have something like say 0.1. And this whole thing here repeats over and over and over again. One of the things that's going to happen is if I gave you a problem like this, and or if I gave you 2 integers that would give you this answer, one of the horrible things that's going to happen is your calculator probably going to stop right about there. It's going to look at the number that's there, say 1 or 0.10, and probably round it to 0.1. So you're not even going to be able to tell that it's a repeating number because the calculator doesn't look at that many decimal places. It is something that can happen. So if we, in these cases, we've got rational numbers here. What is a non-rational number? Something called an irrational number. Basically means that every single digit you have, it goes out to infinity. You never figure out what the actual value is, and nothing ever repeats. So a couple of the things that we can do, at least in math, is we can tell, does it seem like it might be a rational number or an irrational number? If it's a rational number, you can easily come up with these two integers to give you whatever the answer is. If it's an irrational number, because it might repeat after 50 million digits, you never get that far. We just go, all right, if it's that far out, that's irrational. It doesn't repeat. It might, but we won't know. Does anyone here want to try to calculate something by hand out to 50 million decimal places? Yeah, no, I don't either. And for all the math professors, who think that you should be able to do all this sort of stuff by hand, they have to remember that back in the old days, before calculators, how did we do math? There were actually people who would spend 6 months solving one problem and try to write out the answer to as many decimal places as they could. And then once they found their answer, they give that problem to someone else who then does what? Solves the exact same problem. And if they get the same answer out to however many decimal places, they will then take that answer, put it into a book, and then you can look the stuff up on a table. So even mathematicians can't be bothered to calculate these things out to a whole lot of decimal places. And we're all humans here, right? What do humans do? Other than breathe and eat and make gaseous noises every once in a while. What do? We make mistakes. So there have actually been times when you look in those books that are supposed to be the authority on whatever it is, and you do the same problem with the computer and you find, oh, this number's wrong, this number's wrong, this number's wrong, this number's wrong. And from your own personal experiences, if you start adding, subtracting, multiplying, or dividing by the wrong numbers, do you think you get the right number at the end? Exactly. Which means a lot of math pre-computers, so pre-calculators, you're actually getting wrong answers. But it's the wrong answer that was in the book, and we used the values in the book. So at least our wrong answers were repeatable. Right? See what else we have here. So it says here, I noticed that numbers can belong to several sets at once. We already talked about that. And then you look at the diagram here. And that just looks like a huge mess, doesn't it? And I will say as well, why, without looking at, say, this thing right here, why was everything written with all those circles the way that they are? Anybody want to guess?
The amount of elements, really.
Well, it has to deal with the amount of elements. But just if you look at this circle here versus this circle here, why are they so close at the bottom, but so far away at the top? Wait, I'm done. Could you, again, without talking about this guy here, could you actually say rewrite this whole thing and make it look like a big bullseye or big target with equal space above and below? Yeah. So if any of you are OCD that way, and we've got to draw something like that, feel free to make it look like a big freaking target, okay? So again, why is it there's so little space at the bottom, so much space up at the top? Tradition. If we had everything in here equally spaced, uh, I might be able to write up here that this big outer circle is A. And then in here it's B, in here it's C, in here it's D. And then in the last circle in there is set E. And if you put them equally spaced, it might be hard to write a big enough letter between them. So I'm not going to worry about that too much. And yeah. So according to this, that is actually everything that we've got. So what is your in-class homework problem going to be? Or problems? Anybody want to guess? That was a lot. You make this one easy. So with this, if you want to tear a page out of your notebook, go ahead and do that. But make sure you're not giving me a page that's got your notes on it. If you want to tear a page out of your notebook, careful. We're sitting in the get people sitting next to you. I'm fine with that too. You don't need to worry about that. So I'm fine with that. But just for today, when I'm asking about the last math class that you took, I do not need your grade. If you want to tell me what you got in the class, that's on you. I'm not asking for it. Part of the reason for that is it's actually something I forgot to mention during while we're looking at the syllabus. All of you, is everyone here over the age of 18? As long as, okay, if you're over the age of 18, and let's say your mom sends me an email and says, how's my son, how's my daughter doing? My answer to them is, I can't tell you. If you're 17, 16, if your parents ask me how is my son or daughter doing, I can tell them. And it comes down to if you're over the age of 18, you're considered an adult. As an adult, unless you give special permission for, say, a parent or your parents, your grandparents, or whomever, and it's something that you actively have to do, I can't give out your grade. I can talk with them about generalities. Just as an example, a couple of years ago, I had a student who had a mental crisis and ended up missing 3 weeks of an 8-week summer class because he was in a mental facility. I was able, since the grandparent was talking to me about that, I was allowed to say, yeah, I realized that. But when she asked me, so other than those 3 weeks, how's he doing? I couldn't say, well, your grandson has, or your nephew or whoever it was, has like a C+ in the class going into those 3 weeks, blah, blah, blah. All I could say was, he missed it quite a bit. Can't say anything more than that. And even if you did fill out the form to say that I can talk with your parents about something, I have no idea how to access that. So I have no idea whether or not you did that. So I'm always going to tell them, sorry, I can't do that. Talk with your kids. Definition. Okay. Says the blank of two sets, A and B, is a set containing all the elements contained in either A or B or both. The union is denoted as A union B. So what are we looking for? A union. Not an ununion union. A blank of two sets A and B is a set containing only the elements that are in blank sets. And then what does it say right there? The intersection. One of these problems are like, shoot us to this block. If that you just got five, or if you just got four from the previous answer, blah, blah, blah. So some of these answers are right in the problems. And when you're done, you can just come on up, drop off your sheet, and then you know how to use the door, right? You can walk in and out.
It's not working.
Okay.
It's saying, I'm gonna try and get it done after class, but can I email you?
Yeah, that's with Apple products. You're gonna have to go into some of the settings you have.
It's like really good with technology.
Yeah, that's fine.
Okay.
Yeah, and all the homework stuff is due 2-3 days from now. So you'll have time to fill in the stuff, all right?
Hey, what? Sorry.
No problem. The tutoring gentleman from the tutoring center is here. Pretty much all he passed out a flyer like the one that's on it. Yeah, so he's just talking about what happens at the tutoring centers. And, for this class, you do have homework. If you go to our Canvas site, you go to home. And what you see on your side is going to look completely different than what's on my side. But you can see things on the Venn diagram are due on the 28th.
Those are on a different, essential to a different.
Yeah.
Okay.
Yeah, so if you click on these, what should happen is you have that. And then after you click on there, launching a new tab. The woman that was up here before you had a Mac and was having issues getting that to open. I'm gonna guess most people are gonna have issues with that. And since you've got your computer open, you're probably having issues too. So, how did I know? It's almost as if I've done this before. So what should happen is you click on that, it'll take you to the homework that is specific for you. You can work with your friends on it, but one of the things that's gonna happen with Newton is problems you get, problems your friend get are gonna be slightly different.
Okay.
It's like if we're talking about, is it a rational number, yes or no?
Mhm.
You might get 2 and 3, your friend might get 1 and 2.
This one makes it.
It's the same idea, it's just different numeric values. Sometimes we can do exams online and that prevents cheating. Because if you put down, or not saying you, but
But
in general, a student in the class puts down their friend's answer.
in general.
The computer will accept it, it's just will mark it wrong.
Yeah.
Makes it so much easier on me to grade, right?
Thank you so much.
Yeah.
I tried,
Instead of them.
tried getting to the link and it told me to lock. I don't know what's wrong. Sorry, my computer's good, so.
Yeah, no problem. So again, if you go to modules. There's this Newton, the student registration thing. So you have to go through all of these things. Looks like you might have to buy this stuff. Uh, Single term access might be the cheaper option here. But you're gonna have to like go in and purchase this and then follow everything that's in here. And if you are having issues with it, you can contact Newton. I will say at the beginning of the semester, they do get backed up. And the first time I used Newton, no one got back to me until November. So no one in my class could do anything until November. So just a little bit of issue, right? So in the first couple of days, it is going to be, or it's not going to be straightforward.